Question 771. For the curve given by x is equal to square root 2t plus 1 and y is equal to t squared minus 5t plus 2 for t is greater than or equal to 0, what is the equation of tangent line to the curve at the point determined by t is equal to 4? The equation of the line is always equal to y minus y1 is equal to slope m x minus x1, right? That's point slope form. And we have to find the slope, right? Slope of parametric equation is, well, slope is dy over dx, but y is in terms of t, x is also in terms of t. So we're going to write slope as dy over dt over dx over dt, right? So let's find dy over dt first. So dy over dt is equal to, that's a derivative of this equation with respect to t, right? So that's a 2t minus 5. And dx over dt is equal to, here we have x, and x is equal to 2t plus 1 to the power of 1/2, right? So derivative of that, power rho 2t plus 1 negative 1 over 2 times derivative of 2t plus 1, chain rule, right? So 2 cancels out. So that's going to be equal to 1 over, since we have negative exponents, 1 over 2, that's root, right? So root 2t plus 1, right? So our slope is equal to dy over dt, dx over dt, and we're trying to find the slope when t is equal to 4, right? So if we substitute 4, that's going to be 8 minus 5, 3. So 3 over, when t is equal to 4, that's going to be 1 over square root 9, right? Which is 1 over 3. So 1 over 3. So our slope is 9, right? Now we have to find the point x1, y1 that this line passes through, right? So when t is equal to 4, our x value is square root 2t4 plus 1, which is equal to 3. Square root of 9 is 3, right? What about y? Y is 4 squared minus 5 times 4 plus 2. So that's going to be 16 minus 20 plus 2. That's going to be negative 2, right? So the point x1, y1 is 3, negative 2. So finally, our equation of the tangent line is y minus y1. Y minus y1 is equal to slope 9, x minus x1, 3, right? So y plus 2 is equal to 9, x minus 3. This is our equation of the line. Question 772. Use the tangent line found in problem 771 to approximate the value of y when x is equal to 3.1. Okay, the equation of tangent line from question 771 was y plus 2 is equal to slope 9, x minus 3, right? This was the equation of tangent line at t is equal to 4, right? And we're going to use this equation to approximate the value of y when x is 3.1, right? Let's say we have a parametric curve like this, and when x is 3, we have negative 2 here, right? And slope of this tangent line was 9, right? And we're trying to approximate when x is equal to 3.1, right? When x is 3.1, suppose that this value is 3.1. The actual value is right here, but we are using this tangent line to approximate this value, right? So when x is 3.1, substitute 3.1 for x. Then we have y plus 2 is equal to 9 times 0.1, which is equal to 0.9. So y is equal to negative 2 plus 0.9, which is equal to negative 1.1, right? This is our approximation. So this value right here, that's negative 1.1, right? Question 773. Find the point on the curve where the tangent line is horizontal and vertical. Okay, in parametric curve, we have horizontal tangent line when dy over dt is equal to 0, but dx over dt is not equal to 0, right? And we have a vertical tangent line when dx over dt is equal to 0, but dy over dt is not equal to 0 at the point, right? We know that dx over dt was equal to 1 over square root of 2t plus 1, and dy over dt is equal to 2t minus 5, right? When we look at dx over dt, this expression is not equal to 0 for all t, right? In order this expression to be equal to 0, numerator must be equal to 0, right? But numerator is always equal to 1. So this expression is not equal to 0 for all t. Does that make sense? dy over dt is equal to 0 when t is equal to 5 over 2, right? So we do have a horizontal tangent line when t is equal to 5 over 2. Does that make sense? And the question is to find the point on the curve where the tangent line is horizontal, right? So the point at t is equal to 5 over 2 is x is equal to square root 2 times 5 over 2 plus 1, which is equal to square root of 6, right? What about y? Y is equal to 5 over 2 squared minus 5 times 5 over 2 plus 2. So that's 25 over 4 minus 25 over 2 plus 2, right? If you use a calculator, that's going to be negative 17 over 4. All right, so we do have horizontal tangent line at the point square root of 6 comma negative 17 over 4. And what about vertical tangent line? We don't have any vertical tangent line, right? Since dx over dt is not equal to 0, we do not have a vertical tangent line, because in order to have a vertical tangent line, dx over dt must be equal to 0, right? Question 774. Find the second derivative at t equal 4. Alright, we already found out our dx over dt was equal to 1 over square root of 2t plus 1, and dy over dt is equal to 2t minus 5, right? So our first derivative, dy over dx, is equal to dy over dt over dx over dt, right? That is 2t minus 5 over 1 over square root of 2t plus 1. And if we simplify this, that's going to be 2t minus 5 times the square root of 2t plus 1. That was our first derivative. And now we're trying to find the second derivative at t is equal to 4, right? The second derivative is given by derivative of first derivative with respect to x, right? But as you see it, our first derivative is in terms of t, right? So we're gonna differentiate our first derivative with respect to t, and also differentiate x with respect to t, right? So that is equal to derivative of this first derivative. We're gonna have to apply product rule, right? So derivative of 2t minus 5, that's a 2, and we have square root of 2t plus 1, plus we have 2t minus 5 times the derivative of square root 2t plus 1, that's 1 over square root 2t plus 1, right? Dx over dt, that's just the derivative of x. It's right over here, right? 1 over square root of 2t plus 1, right? Now, let's simplify this expression by multiplying 2t plus 1 in the numerator and also in the denominator, 2t plus 1. Then that's going to be equal to, here the denominator is equal to 1, right? This cancels out. So we're going to multiply this by this plus this by this term, right? So that's going to be 2 times 2t plus 1 plus 2t minus 5 times 1, right? So we don't have to write it. So that's going to be equal to 4t 2t, 60, plus 2 minus 5 minus 3, right? Now, our second derivative at t is equal to 4 is then 6 times 4 minus 3, right? That's going to be 24 minus 3. That's a 21, right? Question 775. Determine whether the approximation found in problem 772 is underestimated or overestimated. In question 772, we found out the linear approximation at t is equal to 4, right? When t is equal to 4, x was 3 and y was negative 2. So we had at 3, negative 2, we found the linear approximation at x equal 3.1, right? From the question 774, we know that our second derivative at t is equal to 4 was 21, right? Which is positive. So the parametric curve is concave up at this point, right? So the curve is concave up like that, right? If the curve is concave up, we know that this approximation is underestimated, right? So at 3.1 right here, let's say this is 3.1, then approximation is down here when the actual value is right up here, okay? So our linear approximation is underestimated. Question 777. Write but do not evaluate an expression involving one or more integrals that gives the length of the path described by the parametric equation for t is from 0 to t is equal to 1. Okay, the arc length of the parametric curve is given by integral from 0 to 1 square root x prime of t squared plus y prime of t squared dt, right? Here, x prime of t is equal to 1 over square root of 2t plus 1, and y prime of t is equal to, the derivative of that is 2t minus 5, right? So our arc length from t is equal to 0 to t is equal to 1 is integral from 0 to 1 square root x prime square. That's going to be 1 over 2t plus 1 plus y prime square 2t minus 5 squared dt, right? So this is the integral expression of the parametric curve.